Hello, welcome to the 4.04 homework video. This is all about sets and different notations. I would say this is one of the more challenging homeworks for kids just because there's a lot to remember. So hopefully this video is going to be some help. All right, number one, in each of the following, a verbal description of a set is given. Write the elements of the set using roster notation. All right, so that's the question is, what is roster notation? Well, if we think about a roster on a sports team, it's just a list of all the players that are on the team. So roster notation is just a list of all our options. So A says the set of all months that begin with the letter A. So what we're going to use is we're going to make these little fancy braces that we saw in class, and we just list all the months that begin with A. So I guess the challenge here is you actually have to know which months begin with A, but April and August. All right. And then we close our braces, and that is our roster notation. It's just a list of our different options. Okay? B says the set of all whole numbers. So if we remember from the beginning of the year, whole numbers cannot have decimals, and they cannot be negative. So the set of all whole numbers that are greater than 6, notice that it says greater than 6 and not greater than or equal to 6, and less than 11. So the first whole number that's greater than 6 is 7. Then we also have 8. Then we have 9. Then we have 10. We're not going to be able to list 11 because it says less than 11, not less than or equal to. So that's going to be the end of our list, and then we close our braces here. Moving on, number 2. The number line below shows the graph of a set of points. Write the set using set builder notation. Now, as we talked during class, set builder notation is just kind of the more formal way of writing an inequality. It's no different than writing an inequality. We just put a little extra notation to make it look a little more formal. It's the difference between, writing an essay in your English class versus, texting to your friends. So the extra notation that we have to write, and we gotta remember this, is the brace and then x colon, which stands for x such that, and then after that it's a regular inequality. We look to see what number our dot is on. This is on 1, so it's going to be x and then a 1, and then we just have to figure out what inequality do we use. Well, there's a shaded in circle, so we know there's going to be an equal sign. And it's all the numbers that are greater than 1. So this is x is greater than or equal to 1. All right. Number 3, represent each interval graphed below with interval notation. So interval notation, that's where when you have a less than or a greater than, you're using parentheses. When you have a less than or equal to or greater than or equal to, you're using brackets. And just remember, anytime that infinity is involved, infinity has to be next to parentheses. So if we look at this one that we have right here, we have a dot at 4, and then we have an arrow that's going all the way down. It just keeps going down to negative infinity. So when we do these, the smaller number always has to go to the left, so you can't get any smaller than negative infinity. The bigger number goes on the right. In our case, the circle is on the 4, so we put a 4 there. Now, infinity always has a parenthesis next to it, so that's going to be parenthesis. And then on the 4, because it's an open circle, we're going to use another parenthesis. All right. If we take a look at the second one here, this is a compound inequality. So we have circles on two different numbers, -4 and 4. So those are the two numbers that we're going to use. We're going to use -4 and 4. And then if we look, -4 is a shaded in circle, so that's our bracket. +4 is an open circle, so that's our parenthesis. Number 4, the set of all real numbers less than or equal to 5 could be expressed as, all right? I find it helpful when doing these to make the graph. When we learned how to do these, we started by looking at graphs. So when they give them to you verbally, I think it's not a bad idea to make a quick little graph. So here's 0, here's 5, here's negative 5. The set of all real numbers less than or equal to. So less than or equal to is going to be a shaded in circle on the 5. And then since it's less than, it's going off to the left here. So once we have this, I think it's a little easier to visualize what's happening. All right, our lowest possible answer is way down here at negative infinity. Our highest possible answer is up here at a positive 5. And then we just have to remember our rules. Infinity is always next to parentheses. And then because that's a shaded in circle, we want a bracket. So if we look through our answer choices, that matches up with number 4. All right, let's take a look at the back. So number 5, I'm going to give you a break from the notation, and we're just going to go back and practice some solving. So solve and graph each of the following. I bet you never thought you'd be happy to see just a regular inequality. So negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10, less than 4. All right, so we're going to subtract 10 from both sides. Negative 2x is less than negative 6. Divide both sides by negative 2. And because we're dividing by a negative, we have to remember that that inequality flips around and it becomes x is greater than 3. All right? So it says solve and graph, so off to the side here I'm just going to make a quick little sketch. I'll put a 0 in the middle, I'll put a 3 here, I'll put a negative 3 here. X is greater than 3. There's no equal sign there, so that's an open circle. And then because we're greater than 3, we need to go off to the right for all the numbers that are greater than 3. All right, let's try another one. Negative 2x plus 5 is greater than 17. So focus on the opposites. Plus 5, minus 5 to both sides. We get negative 2x is greater than 12. Divide both sides by negative 2. There's that dividing by a negative again. So it switches from a greater than to x is less than negative 6. All right, if we're going to make our graph, just a quick sketch here. There's 0, there's 6, there's negative 6. All right, again, no equal sign, so we're looking at an open circle. And then it says less than negative 6, so that puts us off to the left here. We want all the numbers that are smaller than negative 6. Okay. One more here to solve. We've got variables on both sides, so we're going to need to move those over to the same side. So 3x plus 5 is greater than 2x minus 8. Let's move the smaller variable. So that's a minus 2x, a minus 2x. 3 minus 2 is 1. You can write 1x, that's not wrong, but I'm just going to write that as x because it means the same thing. So x plus 5 is greater than negative 8. Make sure that minus sign comes down with you. Subtract 5. X is greater than negative 13. Okay, so again, one final graph here. There's the 0, there's the 13, there's the negative 13. All right, again, there's still no equal sign. None of these had any equal sign, so we're going to keep using the open circle, which tells us that negative 13 is not part of our solution. And then this is greater than, so we want all the numbers off to the right, all the numbers that are larger than negative 13. Okay, breaks over. Back to the sets. Describe all real numbers greater than negative 18 in set builder. So the key here is remembering which one is set builder. Set builder, if we go back to the front, was just the one that uses kind of the more formal notation. So we're going to need our brace. We're going to have our x and then a colon, which stands for x such that, and then describe all real numbers greater than negative 18. So that's really just x greater than negative 18. This all real numbers is basically our x. So this is x greater than negative 18. So it's not that these are hard, it's just they use a lot of kind of fancy words that make them, a little more confusing than maybe they had to be. All right, so this is x such that x is greater than negative 18. 7. Describe all of the real numbers less than or equal to 9 in interval notation. And then I gave you a little hint here. Graph it first. This is where we have those parentheses in the brackets. So I think it's just helpful to visualize that on a number line. All right, there's 0, there's 9, there's negative 9. All real numbers less than or equal to. So since it's less than or equal to, we need a shaded in circle. And then if we're less than, that's going off to the left. So now that we have this picture, we can kind of visualize what's going on. Our solutions go all the way down to negative infinity. And since we always put the smaller number on the left, we're going to start with a negative infinity. And then they go up to a positive 9. At this point, it's just remembering your rules. Infinity is always next to parentheses. And then because that's a shaded in circle, we need a bracket there. So that would be our final answer. This is what we call interval notation. All right, I hope this was of some help. Have a nice day.